Hello, everybody. This is Mr. Sullivan making this video to help you with the lab so that you guys can finish that. So you have solubility potassium nitrate. These are notes. Answer the notes, no big deal. I posted this on the board. You got 94.94 out of 20. Well, what is that out of 100? Simple, just multiply it by 5. Answer those questions based on your ability, based off of your knowledge. Simple. Now, you've done the lab and you've gotten your data. So we're going to look at my made up data, made this data up. And so this is what my 4 test tubes have crystallized at. Okay, so now that's my x-axis. So when we go over here, we now need to do our y-axis. And our y-axis is 2 out of 5, 4 out of 5, 6 out of 5, 8 out of 5. But that's not the correct solubility unit. So we need to turn that into the 1 per 100. So just like we did on the front page, where the 20 became 100, the 5's becoming 100. So instead of multiplying with 5, we're going to multiply by 20. So we get 40, 80, 120, 160 out of 100. This gives us our y-axis. And you can see that in the graph here. It explains that the x-axis is temperature and the y-axis is solubility. Now, this graph box I gave you is designed so that you can basically go from 0 to 100 with 3 boxes as 10s. You can set it up how you like, but usually more resolution is better. And you want to make sure you label that axis. In this case, we have temperature, and the unit we're talking about is 0 degree or degrees C. Then over here, we have the y-axis, and we go from, we basically start at 40 and then go up to 160, but I've got lots of boxes here. So I started with 0, so we have a nice 0, 0 axis, and every box is 10. So it was easy to go, 10, 20, 30, 40. And just for the sake of neatness, I only wrote every other number. Pretty simple. But the important part is I labeled it solubility, grams per 100 grams. Probably should write grams potassium nitrate per 100 grams of water, because that's what we watched, or that's what we looked at. Then, of course, we have our title, the effective solubility on potassium nitrate in water, and we graph it. Now, my graph, again, I made up my data, and it kind of gave us good dots there. We want kind of a toss between a line of best fit and a connect the dots. It should be a nice smooth exponential type curve. That's usually what potassium nitrate makes. But again, it's a difficult lab to do. Whatever your data is what it is. So just go ahead and make a best fit line that you can. As per our discussion, everything below that line is what we call unsaturated. So every amount, if we look at like that temperature, if we look at that solubility for 100 grams of water, if it's below this line, it's unsaturated. You'll be able to see it easily dissolve. It'll never crystallize. This is the unsaturated region. This line, that was the line that we made when it was crystallizing, and that line is called the saturation point. That's where the maximum amount of solute fits into the solvent. Everything above this line, if a substance is above this line, it's in the supersaturated zone. So now that you have your graph, you can answer the questions down here. So you've made your graph, and on the next page, it says, what's the relationship between the solubility of the potassium nitrate and the temperature? They're positive, they're correlating. One goes up, the other one goes up. Now your graph might seem like it's linear, it might seem like it's exponential, but either way, that's the kind of comment you're having to make. They both go up together at the same amount. This seems to be higher temperatures cause the solubility to go up a lot. Based off your data, what do you see? And then for this one, you're going to use your graph. You're going to go to these different temperatures, and you're going to see what the actual solubility is at these temperatures. So for my graph, we go to 35. So 35 degrees is like right here. And I don't have data for that one. So you could guess, extrapolate and say that it's, sorry, 35 degrees, not 35 solubility. That's what I did. I drew this yellow line. There's 35 degrees C, and you can go up here and you'll notice it hits the line right there. And that's right around 70 grams per 100 grams of solvent. So according to my data, at 35 degrees, I should see 70 per 100. And then of course you can just do this for the other ones where you go to 60 and you draw your dot and then go across and then figure out what the solubility is. And then you can do that same thing for the other next question, which is 70 degrees. So then once you have that, then you can do this where it's like, okay, go to 75 out of 100, which are my little black dots here. So I go to 75 out of 100, which is, you know, right around here. And I draw a little black dot at the 40 degree temperature, wherever it hits the line. And you'll notice, sorry, not wherever it hits the line, at 40 degrees, sorry. At 40 degrees, it seems to be somewhere, maybe it's hitting the line. It's hard to say. So according to my data, saturated, unsaturated, one of those answers is perfectly fine. But for the next one, according to my data, 60 at 100 at 50, well, if I go to 50 degrees right here, and I go to, what was it? 60 out of 100. So if we go to 60 out of 100, right there, this line, and we go to 50, that's dot there. That's clearly in the unsaturated zone. So now that we have that, we can draw what we think a solubility curve would look like for a gas. And if you guys remember, gases are affected negatively by increased temperatures. So while solids tend to have positive slopes, gases will have negative slopes. So if you just basically draw a graph with the same scale if you want, or you can make it smaller, and you notice that you have a nice downward slope, that's what they want you to draw in those boxes there. So that's how you finish up the lab, and you can work on that very easily. Once you do the graph, all the answers are basically just taken straight off the graph. So make your graph, make it nice and labeled, just like mine, got all the axes labeled and all that kind of stuff. And then you can answer the questions from there. And that's how you finish the lab. Good luck.